Aveva fatto partire lei, quindi.
Started the meeting.
Okay, good morning. I am just waiting for the last attendees to join. Okay, so I think we can start. Good morning, everyone. Again, thank you to be here. Thank you to our speakers and to the attendees, of course, and to the BEPA colleagues that are helping today. So today we are having the second edition of the Battery Startups Launch. So we will have 5 presentations from 5 different battery startups that are also BEPA members. So I want you to join me in welcoming all of them. So Nicola Bozek, Head of Partnership at Basquevolto, Clemens Van Zyl, Managing Director at Hemdalytics, Fanny Bardet, Founder and CTO at SOLiTHOR, Fouad Gamdoman, CTO at the Reliability, Safety and Technical Center, and Scarlett Dufy, Sales Development Representative at Echion. So thank you again. So the purpose of this series of webinars that we are organizing is really to connect the battery stakeholders, to listen to the battery startups and understand their needs, to discover their products. So I will now give you really quickly some practical information. So the webinar is recorded, and we will share the recording and the slides afterwards with you. And then if you have questions, you will be able to put them in the Q&A chat. So every speaker will have 10 minutes time, and you then will have time to ask your questions. And yes, I will also I also wanted to let you know that it's already possible to register to our third edition of the Battery Startup Launch that will take place in September 10th. So then we will be sharing the link in the chat so you can register. And we'll have also 5 other battery startups that are also BEPA members that will showcase their innovation. So now I leave you to the presentation, because the purpose is to listen to our battery startups today and discover the technologies. So let me introduce our first speaker, Fanny Bardet, Founder and CTO at SOLiTHOR. Please, Fanny, the floor is yours, and I let you share your screen.
Good morning, everyone. I hope you can hear me well. First of all, this is a pleasure to be here. So I would like to thank you, the BEPA, for inviting us to this Battery Startup Launch webinar. Today, I would like to introduce you to the company SOLiTHOR, which I co-found and where I am today active as a Chief Technology Officer. SOLiTHOR is basically developing all solid-state battery. So if I would like first to introduce you SOLiTHOR in very brief. SOLiTHOR is on his way to become a European champion for all solid-state battery. In a nutshell, our technology is based on a unique and proprietary solid composite electrolyte. We have access to over 16 patent family as a background, and we of course have filed a series of patent applications since the company was created 3 years ago. Today we are 33 employees in the company. We have a high number of PhD and master degrees within the team. So far, the management team has been able to raise 20 million, and we are located in Belgium in the city of Sint-Truiden. Our mission at SOLiTHOR is to develop a breakthrough rechargeable solid-state lithium batteries to unlock the barrier to electrification across high-value mobility segment. To be a bit more precise on that, so SOLiTHOR is targeting to power next-generation electric aviation and defense application. But also look at premium consumer appliance and high-end electric vehicles. So SOLiTHOR solid-state battery technology will serve segment where there is a need for high energy density due to weight or volume restriction. And also, of course, we would like to increase the safety of the cell while increasing at the same time the energy density, increasing safety for high-risk environment applications, such as, for example, as I just mentioned, the aerospace, defense, and aviation sector. You are probably well aware that this sector is growing and is expected to grow even further by 2035 even. Related to the consumer and industrial appliance, conventional lithium battery have reached their limit, and we believe that there is a space for solid-state battery for a new wave of product with higher specifications. Last but not least, of course, the terrestrial, maritime, and transportation sector. SOLiTHOR foresee to be able to address this market on the later stage, where obviously high energy density, high value would be very relevant for high value segments, especially also where safety is critical. So what we have done so far, we believe first that SOLiTHOR has the right setup to be focusing and is focusing at developing its original next generation battery technology. There are 3 pillars for that. First of all, we have a very strong heritage. We are basically a startup, a spin-off of the prestigious semiconductor research institute IMEC, located in Belgium. IMEC, before the creation of SOLiTHOR, has already spent 10 years looking at this and developing the nanotechnology, nano-solid composite electrolyte, which is the core of our technology. So basically, SOLiTHOR is leveraging on 10 years of R&D, which was taking place at IMEC. And we have a specific license agreement with IMEC to exploit the technology and license further to our customer and partners. Second point, we believe we have a very strong technology-driven team. As I just mentioned, we have 35 full-time equivalents, with 70% of our employees having a master's degree and PhD degree. We are also a very seasoned leadership team with a very strong combined industrial experience so far. The third point, of course, is that we have a very strong focused effort on battery innovation. So as I will come up later on, we are today located in Sint-Truiden in Belgium, where we have a 3,000 meters square of purpose-built facility, equipped with a 380 meters square dry room and advanced cell assembly and testing capability. For us, this will enable us to demonstrate the added value of our technology. Now, if we look at the development from a technology point of view, so in the last 3 years, so SOLiTHOR has continuously developing and validating the technology from lab to multi-layer battery cell testings and upscaling. So in 2021, when the company was created, basically the material was available in milligrams, and mostly there was a proof of concept which was released in the size of a coin cell and several coin cells. What the company has been doing over the last 3 years was actually to start refining the recipe related to the solid composite electrolyte, and we start to produce thin film component of that material. In 2023, as I already mentioned, we moved to our new facility, which enabled us to speed up our learning curve and our developments. In 2024, we have made a press release where we announced that we had been able to demonstrate the cyclability of our solid composite electrolyte, where a pouch cell were able to demonstrate more than 1,000 cycles at 25 degrees and at a moderate pressure environment. So we have been able to validate these very important KPIs in a pouch cell. In the meantime, the team has been developing and validating multi-layer pouch cell in a range of 1 to 3 ampere hours. The focus of the team for 2025 will be to move from a sheet-to-sheet process to a roll-to-roll process, and also to move from a manual process for the cell assembly to a semi-automated assembly process, while of course continuously iterating on the core formulation of our solid composite electrolyte. While we are developing the technology, of course, we are reinforcing our company profile and management team. So as you see, as I mentioned, I'm the co-founder and CTO. Next to me, we have Rodrigo Navarro, the CEO of the company, who has a strong background in semiconductor industry from the past. We also have strengthened the team by recruiting Karel Fittier, head of material, who has a strong background in polymer and chemistry industry. Over the different years, as we mentioned, we have been successful in securing more than 20 million into funding from our different investors, being SFPIM, IMEC Expand, LRM, Numa, and NOSHAC. Besides that, we also were able to secure a non-dilutive funding from VLAIO and the European Regional Development Fund to support our CapEx investments. More recently, we were also able to secure an additional 5 million. Obviously, as a startup, we are still looking for further funding. SOLiTHOR, we believe, is well positioned for acceleration and scaling up with partners. So today, one of the purposes of being there actually is really to connect with different companies across the battery value chain in order to speed up our roadmap and our way to market and to product. So SOLiTHOR, as I mentioned, is able to accelerate by a robust combination of market collaboration. So today we have different strategic partnership with end user. We also have different partnership already in place with battery material suppliers. Beside that, as I mentioned, we believe well located in the north of Europe, very close to the battery valley, as it's called, in the north of France and south of Belgium. So we believe we want to reinforce that interaction with the different players and actors around the battery value chain. As I say, we are very strongly bonded with public funded instruments, such as the Belgian and the European ones. We believe that we want, as I say, to exchange more along the battery value chain. So I'm very welcoming different partnerships. So SOLiTHOR basically is looking for more strategic partnership and investors forwards. So we would like to reinforce collaboration with startups. So I already saw different of my colleagues who will present after, which I'm very keen to talk to. And obviously, as a startup, as we mentioned, we are also seeking for strategic investors to invest further in our company. And with this, I would like to thank you for your attention. And I will welcome some questions while I will stop sharing to be able to see people.
Yeah, thank you.
Thank you for. Okay.
Sorry. Thank you, Fanny. Thank you for your presentation. I will read you a question that we got in the Q&A section.
Mm-hmm.
About the types of anodes and cathodes that you use.
Okay, so most of the demonstration we have made so far, so we use basically a lithium anode, lithium metal anode on one side. For the cathode, we have already tested the technology with lithium iron phosphate and NMC, different flavors of NMC, mostly focusing on MNC 622 and 811 so far. But of course, this is not limited. In the future, we want to expand and to test and prove the technology with other type of cathodes. So this is not, we are not excluding any type of cathodes there. I hope I answered the question.
Thank you again, Fanny. And in any case, the attendees can contact you for further questions.
For sure. Yeah.
Thank you.
Thank you.
I will now give the floor to our second speaker, Nicolas Bozet, Head of Partnership at Basquevolto. So please, Nicolas, the floor is yours, and I will let you share your screen.
Thank you, Elena. Just share my screen. Can you see my screen properly?
Yes.
Yeah. Okay. Well, thank you for the opportunity to tell a bit more about Basquevolto. So Basquevolto, like SOLiTHOR, with a next generation battery technology company, lithium metal based. So you've all seen the headlines. You know, the European Union wants to move to 100% electrification towards 2035, but EV sales are slowing down, and European gigafactories are also struggling. But here's what most people don't realize is that the battery that are used in today's electric vehicles still rely intrinsically on the same technology that was introduced in 1991 by Sony for its camcorder.
Sorry to interrupt. We see the presenter view, the presenter mode. If you go on the three dots there that you can see, you can hide presenter view.
Better?
Yes. Thank you. Yes, now we
better.
see it.
Sorry
Thank
for
you
that.
So much.
Yeah,
excellent.
So I was spoiling the surprise. Yeah. So here's what people don't realize is that the battery that are used in today's electric vehicle essentially rely on the same technology that was introduced in 1991 by Sony, the lithium-ion battery. And this is really where Basquevolto steps in. So with Basquevolto, we're working to address the current blocking point of 100% electrification through technology by addressing the cost aspect. We target 30% cost reduction towards versus existing lithium-ion battery and 50% higher energy density. And where we are also unique is the fact that we are doing this while remaining compatible with the existing lithium-ion gigafactory equipment, processing equipment, which I think is key given the situation of the current gigafactories. So Basquevolto is partly public and partly private. So we are both the Spanish and the Basque government as shareholders because there's a lot of jobs tied to the automotive industry in the Basque countries. And when the Basque country politicians realized that the transition from ICE to EV could have direct impact on their ecosystem, they decided to bring over Michel Armand to establish a research center. And when the company was ready, Basquevolto was spun off. We also have key Spanish entities as utility companies and in our capital. So Basquevolto is a new company. We are about 3 years old, but in less than 30 months, we went from being incorporated to delivering our first 80 ampere-hour cell, which is an automotive size cell. And this year is the year of where we're going to start to enter commercialization. In this short time, we've already won quite a few awards. I'm especially proud of being part of the EIC Scale-Up Club. So we are part of the 100 startups in Europe aiming to become unicorns within 5 years, as well as the SET Award finalist by the German Energy Department. So I mentioned it quickly, but the reason why we're able to go so fast is because our technology comes from this gentleman. So Professor Michel Armand is one of the forefathers of today's modern battery and has been a leading battery research figure for the last 40 years, unlocking LFP amongst others. But also, we were when we decided to create Basquevolto, we ensured that we were splitting equally our executives amongst battery and scientific experts, but also industry experts. So you see here quite a few logos from the automotive industry, which made sure that we would focus not just on the technology and achieving excellent performance, but also on ensuring that we would deploy this technology quickly and at cost, hence the cost reduction that we're introducing, which is unique. So we're also going really fast by focusing on what makes us unique. So the battery value chain is extremely complex. We've seen what happens when companies try to tackle everything at once with Norvolt. So here at Basquevolto, we really decided to focus on what makes us unique and to leverage partnerships with the rest of the ecosystem to, again, keep the pace. So here we're really focusing on the electrolyte and the lithium metal protection. Our technology, here you can see on the left-hand side the standard lithium-ion battery with the graphite anode and the copper current collector, which we're able to replace by the lithium metal foil, extremely thin, which gives us the energy density benefits that I showed before. Our technology is cathode agnostic. So today we're working on NMC and LFP. And here you could say with NMC, we are breaching 1,000 watt-hour per liter and 400 watt-hour per kilo. And with the LFP variant, we're able to reach today's NMC lithium-ion energy, all the while ensuring cost reduction and increased safety. Here you could see clearly where we stand versus the current battery technology and historical battery technology. So we're right at the top chain, where we also discovered that although the company was created to address automotive application, that the energy density that we were providing could help unlock application in other domains, such as aerospace and defense. Here you can see a quick representation of the standard lithium-ion manufacturing line, where with our technology, we maintain about 90% of the equipment. We no longer need the anode lines, saving capex, but we're going to repurpose that. We save a lot of energy, information, and aging by using a lot less time. With ours is about 24 hours. Which saves also a lot of capex with machines and square meters. And the only part that we need to adapt is really the stacking machines to comply with the inherent properties of lithium metal. So Basquevolto has a business model that's based on 2 revenue streams. So we're going to be building a pilot line next year, which is going to be a 1 gigawatt-hour block, which will demonstrate that our technology is not only able to achieve to function on the existing lithium-ion gigafactory equipment, but also sustain the same production rate. So we will have that block, but really that block is just a demonstrator. But when it will be done, we will keep using this facility to supply battery to what we call the niche applications, such as aerospace, defense, aviation, and marine. But most of our business will be to supply the technology to the European gigafactories. I touched upon it a bit earlier at the beginning of my presentation, but the European gigafactories are really struggling today because they're essentially trying to manufacture in Europe the same technology that China has been doing for 10 years with full control of the supply chain, the machines, and the know-how. And without technological differentiation, it's very difficult to be sustainable. So we are going to be giving them the technology to keep using their same industrial tools and produce cells that will be competitive without subsidies. Here you can see our facility. So this is a real picture where I'm located right now. It's our technical center located in the Basque Country, Spanish Basque Country in Vitoria. We've invested 20 million just in this facility. We have our own lab, which you can see here, where we synthesize our own lithium salt and electrolyte, as well as manufacture coin cells, 1 ampere hour and 5 ampere hour cells in this lab. This is a fully automated stacker on the picture here. So we are, even at this size, we're able to do it fully automatically, and the testing equipment. But we also already have a fully automated line, which is still an R&D tool, but 50 megawatt hour capable, where you see it's completely standard lithium-ion equipment that's still able to fully output 20 and 80 ampere-hour cells today, as well as you can see on the bottom left-hand side, where we make our own electrolyte in much larger quantities. So this is just a quick introduction for Basquevolto, but you know, in a nutshell, Basquevolto is a next generation battery technology company, fully European. We deliver 50% more energy, 30% lower cost, all the one remaining compatible with the existing lithium-ion gigafactories. Today, we have an unmatched speed of innovation and industrialization, about 5 times faster than our competitors. And we really see ourselves as an accelerator of the competitiveness of the European ecosystem. We don't compete head-to-head with any of the established players. We're really here to unlock the competitiveness of Europe and ensure that we have sovereign technology going forward. And that's it for me. Thank you for your attention.
Thank you, Nicolas. I see there are some questions in the Q&A section. So I'm reading you the first one. Are the stated cost reduction and energy density improvements relative to Asian Chinese manufacturers? And do you plan to be a direct competitor to Asian producers? And second question is, do you also produce LFP and NMC cathode materials, or buy them, and from where?
Okay, so as maybe those questions came before I fully explained, but essentially we see our business as being a technology provider to unlock the gigafactory. So we are not going to be making the cathodes. We see this being really like the business of the gigafactories, and in fact, they spend a lot of R&D time optimize the production of these cathodes. All the players that we are talking to, they really want to keep that part of the investment that they've done, and we are going to tweak our chemistry to be fully compatible with theirs. Obviously, for our gigawatt hour and what we're doing today, we are manufacturing our own, but that's not really the point of the technology. Where we make a difference is really by being able to leverage the lithium metal with existing manufacturing equipment to deliver this really high energy density and keeping cost under control. With regard to the cost competitiveness, yes, the idea is to be competitive globally. So yes. Any other questions?
Yeah, I see other questions, but as I said previously in the chat, you should also see them. Let me know if not, I can share them with you, but you should be able to also answer.
So do we make lithium anode in-house? So at the moment, the lithium metal supply chain is extremely scarce, and indeed, most of the lithium metal is coming from Asia. We're sourcing it from Asia, but we're exploring, industrialization in other countries through partnership. Again, our competitive advantage is on the electrolyte. This is where Michel Armand brings this know-how, and we are going to find the best way to supply the lithium metal. Can you elaborate on the simplification of the formation step? It's just much faster. It takes 24 hours. Okay.
Thank you. I think we
Feel
are
free to
running.
reach out. You have my email in the invitation.
Yes,
so if you have more questions or we want to have a deep dive, happy to.
Yeah, for sure. And I also wanted to say to you, the speakers, that you should be able also to write the answers in the Q&A section now. You should be able to see if there are other questions. So if we don't have time during your slot, you can just answer them now. Thank you, Nicolas.
Thank you for
I will
attention.
now introduce our third speaker, Fouad Gandoman, CTO at the Reliability and Safety Technical Center. Thank you, Fouad. And sorry, we're just running a few minutes later, but yeah, the floor is yours. I will let you share your screen. Thank you.
It's okay. Thank you so much. I believe you can see my screen. Am I right?
Yes, thanks.
Okay. So first of all, thank you so much for this kind of event and for having us today. So regarding the RSTER, we are an engineering company located in Belgium. We have two locations, one of them in Flanders, the other one in Wallonia, which is a new one. I will give you more information in this case. So just to see, yes. So to be honest, we look at this market from the other perspective, because as you know, there would be different type of the technology from the battery, and then they will bring it to the market. But whenever we have all those technology in the market, in order to hand it over to the right position for the end user, in the Europe, we have a lack of the engineering services. So that's why we come up with this ecosystem in order to support all those producers, especially with the end user, to provide them engineering services within the framework of the three different, pillars. Here you can see we are focusing on very big domains, but when we narrow down to all those big domains, you can see we have three main key components, which is dealing with all those applications. One of them is a battery, the other one is a conversion system, and the last one would be electric motor. So we just focus on those three key components and provide the reliability, safety, and lifetime performance based on our services for the producer and also for the end users. Here you can see the list of my colleagues. So we are quite small at this stage, but now we are dealing with the big project. So by the end of the 2025, we will be 10 engineers, which is dealing with all those services, would bring it to the market. So here's ecosystem. This is just about the battery, but you can expand it to the other components, and also you look at this picture from the powertrain or from the system level. So we have a partnership with the different manufacturers like electric motor, battery, conversion system, and the PV. I will give you the list of them in the other slide. And we are in the middle as an engineering company to provide the multi-domain services in order to facilitate the communication between the manufacturer with the end users, like a design and planning application, feasibility study, project management, and in the new project, we will be able to provide the testing from the safety, lifetime, and the performance from all those key components. And also, we are developing some toolbox for the monitoring the components during the application as well. And we are dealing with the technology qualification based on our new facility. So the domain of our activity related to the battery, as you can see, we would support engineering services from the home storage to the larger energy storage could support a grid. And in this part, we focus on the lithium-ion battery, could start from generation 3 and generation 4 in this case. So here, this is a list of our expertise. Normally, based on the new project, we will be capable to deploy all those safety and reliability testing, which is needed in the market and is a bottleneck to move forward regarding the adaptation the new technology in the EU. We will provide a risk assessment in order to minimize the cost and also improve the safety and reliability during the operation of the system. Provide a feasibility study for both sides, for the end user and also for the manufacturer, in order to know what kind of the application they are dealing with and how they will be able to sell their product with the higher quality in the market. And we also provide the system analysis. We develop a toolbox in order to gather the data, monitoring the data from different type of the asset, and provide a test scenario for the end user. It depends who will be the end user and what kind of the assessment do they need. And also, we developing a predictive maintenance toolbox as well in order to know what would be the downtime of the system. As you know, whenever we go for the new technology, there would be many challenges whenever go for the integration and implementation for different applications. Normally, this kind of toolbox will provide the comprehensive information related to the operation of the system and the support to improve the lifetime performance of the system, and to provide the scheduling maintenance for the owner of the application, and also give more data to the manufacturer to know how the system will behave at the real environment. Here you can see our software. We develop it at this stage. We have a two key toolbox, but this toolbox will be scalable and compatible with different type of application. We have a one toolbox dealing with the predictive maintenance, which is focusing on the wind energy. But as you know, when we go for the different application, like a wind, solar, and also e-mobility application, battery would be one of the key components. Therefore, we are also developing the toolbox for the, at this stage, we're just dealing with the e-mobility application, but in the near future, we want to scale it up for the grid as well, for the home storage, and also for the grid supporting. So in this toolbox, you can gather the different type of the data from the asset, evaluate the data, and also provide predictive maintenance and scheduling for the maintenance. You can provide a risk assessment, reliability assessment, in order to know how your product will behave at the real environment. And here is our partnership with the different type of companies in all parts of the Europe. So we have a collaboration with the battery manufacturer, PV manufacturers, and also company dealing with the assessing different type of the asset from the commercialized from the commercial, and also from the wind farm and the PV farm. And we have a collaboration with the company who dealing with the develop very efficient conversion system. So regarding the other partners, we have a collaboration with the Wallonia region and with the Valeo. So we have two offices, one of them in the Flanders and the other one in Wallonia, the new one. And in the new offices, or let's say the engineering hub, here you can see we start this project because we know that would be a strong need in the market. By growing this market, deliver different type of the technology, we will be capable in our facility to provide engineering services, and also testing for the, especially focus on lifetime safety and reliability for the battery conversion system and also electric motor. So because when we integrate the battery in the different application, we need to know in this system how the system need to react in order to improve the lifetime. Because it's not just this components like a battery, the other components also will impact on the operation of the system. So that's why in our new facility, which is located in Varem in Wallonia, we are capable to deliver this kind of services. Apart from this, since we have advanced and smart testing facility, we will be able to deploy some critical tests, which is need to be considered, especially from the safety, which will be very expensive, and regarding the lifetime would be very time consuming to our clients. This is just for the battery conversion system and electric motor, and at the end to the whole system as one of the unified ecosystem. This is a list of the R&D project or European project. Also, we are engaged at this stage. We have 6 European project. In 3 of them, we are focusing on battery. As you can see in the fastest, we are developing a toolbox for the visualization of the testing of the battery for the safety and lifetime. Our activity is mainly focused on the safety part, and we focus on the e-mobility applications and also stationary. In the Haven, we just focus on the stationary. Here we are dealing with the technology qualification and provide a standardization recommendation for the classification body, because as you know, the other challenge in the battery market would be standardization. So we are active in this case, and we are close with the classification body to support them. And based on our view as an engineer and as a system level, how they can, proceed and provide some recommendation for that. For the skillet, also we focus on the electric trucks. So here also that would be the same field, and we also supporting to develop predictive maintenance, toolbox, and bring our toolbox to that level to be scalable also to the heavy duty vehicle. Yes, this is a short introduction about our company. We will be in the middle between the production and also between the end user and provide this engineering services to the market, especially focus on the safety, reliability, and lifetime performance, which is that's why the name of our company is based on that. So this is our core activity.
Thank you, Fuad. As we're running a bit over time, I suggest that if you can see the questions, there is one in the Q&A chat and one in the meetings chat. If you can see them, I suggest that you write the answers, and then we move on to our fourth speaker. Thank you so much.
Sure. You can see my contact, and please feel free to reach out, and then we can discuss further.
Thank you.
Thank you.
So our next speaker is Clemens van Zyl, Managing Director at Hemdalytics. So please, Clemens, the floor is yours.
Great, thank you very much. It's a real pleasure to speak to everybody today. I'm just trying to put it into slide, but there's a, here we go. How's that for everybody? Okay, Intelligent Battery Management Systems, or for short BMS, Hemdalytics. Dr. Christoph Weber and myself, Clemens van Zyl, we created the company in 2021, and we created the company to solve a specific problem with lithium titanate batteries at the time. And hence we knew we had to make BMSs more intelligent to solve that issue. Battery management systems, the vast majority of batteries will have a battery management system as part of the overall battery energy storage. Battery energy storage, as we already discussed today, decarbonization is driving that. And, I'm a big believer in someday the fusion reactor, hopefully not too far in the distant future, will become reality. And battery energy storage there will even be higher demand for battery energy storage systems and BMSs that go along with it. If you look at some of the industry reports, it's predicted to be a $50 billion market by 2035. It's somewhere around $8 billion today. If you look at capturing a 1% market share, that's 0.5 billion, obviously, by 2035. To do that, in our business plan, we're focused on heavy use applications for batteries, and also where battery safety and reliability is of utmost importance. So how do we make a battery management system intelligent? What we do is we add spectrometry, which is a nice word. A lot of people don't understand what that means right away. And so this is a very simple, everyday example of spectrometry. So if you think of a guitar, you give it an instruction that results into you picking a string and exciting it with a pick. That excites the body of the guitar in this example. You create a sound and you measure it and you analyze it. And the amazing thing about humans is that happens very, very quickly, and we adjust our excitation and we create this beautiful thing called music. So we could do the same thing with a battery. So we can excite the battery. In this case, what you do is you inject different frequencies of current. You measure the response. You have to do that very accurately, that measurement, if you're going to make sense out of the feedback. You compare the feedback to what you excited it with, and you do that with a controller, and you can you can create impedance. Think about impedance it's a representation of the magnitude of the feedback compared to the excitation, but it is also a measurement of the phase shift. And you can then take that to the cloud, and you can do artificial intelligence on that, and you can get some very exciting, precise analytics from that, and hence make an intelligent BMS. So on the left-hand side, the precise analysis with AI-driven EIS. So that previous chart is summarized in the circle called EIS. What we do is we make a full spectrum of impedance measurements. So from very low frequency to high frequency. And by doing that, we make an expanded data set compared to conventional. And conventional systems, they have tried to and certainly have made progress in making them smarter. But what they do is they haven't expanded the data set. They use the conventional voltage, current, and temperature measurements, and they do cloud analysis on it. But that's a limited data set. And Christoph and I knew that when we created the company and said we have to expand this data set if we're going to solve this BMS issue of precise estimation. And so that's what we have done. So why do you want to do this? In the battery world, what you want is precise estimation of battery states. And the states are state of energy capacity, state of anomaly, state of stress, and state of charge. All sounds nice, but what does that really mean in terms of practical terms? State of energy capacity is an accurate status of your aging or remaining life in your battery. You need to know that because you need to know when a battery needs to be taken out of service. Today, the way the automotive companies deal with that, they used to have higher safety factors, but today they typically, what happens in your car is you're carrying 20% extra battery capacity in your car to make it safe because they don't know exactly when any particular battery is going to hit its end of life. State of anomalies is a warning of a pending failure. If you think of the Hyundai and General Motors recalls, each one of those being well in advance of $1 billion, it sure would have been nice if they had a warning in the very early days that there was something going wrong in those batteries. State of stress, well, you want to avoid stressing the battery. And if you stress the battery, you're going to take life off it, and that is not a good event. So you think of fast charging now. Everybody wants to fast charge the batteries, but a lot of people don't realize you're taking a lot of life off your battery. But wouldn't it be great to know exactly how you're stressing that battery so you can feed that back into the charger intelligently, so you absolutely maximize the amount of fast charge you can do without harming your battery. State of charge. In an EV vehicle, this is not an issue, but in applications where you're constantly working the battery, the way we deal with resetting the storage gauge, and that gauge its accuracy wanders as you use it, is you have to go through a long rest period. But in a lot of applications, like a forklift or vehicle, your vehicle sit there for 8 hours. To do a rest period to reset your gauge. So quickly solve that issue. So we have two products that we've incorporated technology in. One is an instrument, one is an online BMS, or call it, I should say, offline BMS, which is an instrument. The instrument is strategically very important because first and foremost, we use it for AI training, because AI is great, but you have to create the data and you have to train it, and then once it's trained, then it can go do its work. So we use the instrument for that purpose, but also to identify healthy batteries for reuse and second use. We match batteries for rebuilding battery packs, and we recertify batteries. And the online BMS essentially creates all those states. We use all those states to identify exactly what the state of your battery is. So we have our competitive advantages, a high accuracy proprietary electronics. We use a full spectrum of EIS for accurate estimation. Not all companies do this. In fact, most don't. And they do that because they don't go for high accuracy because of the additional cost that goes with it. But if we jump to the bottom bullet, we have 4 patent applications and another one in process, and it's all focused on low-cost configuration. So in other words, you get high accuracy without burdening the application with cost. So part of our secret is obviously artificial intelligence. We use deep learning, and we get high accuracy with our proprietary algorithms around that. In terms of our progress, we have an automotive pilot line with Renault that is working. This is very strategic to Renault as part of their overall marketing with vehicles. So with Renault, you don't have to buy a new battery pack. They will repair. It'll be repaired in a fashion that it'll be reliable, and they use our technology to do that. Presently, we're now focused on the development of products on the online BMS. So applications, rebuilds, heavy use vehicles, grid stability, and uninterruptible power supplies. I'll just say a little bit about UPSs. So this is an application which is just typically lead acid. Lithium is encroaching on that, but lead is pretty cheap. One way to make lead more dominant is these batteries are designed for 10 years, but the data centers are replacing them every 3. They do that because they don't have a good, accurate window into what the state of the battery is. If you could add that to the battery, then there's no need to replace these batteries in 3 years. You can replace them every 8 years, or you take them right to end of life, which would be a huge savings for the Amazons and the Microsofts of the world. In terms of our team, myself, I have worked with multinationals, General Electric and Shell, for example. I've been have one other startup, worked with early stage companies. Christoph has worked for Jungheinrich, so he has a lot of practical experience in industry and experience in commercializing products. But he's a professor at the University of Applied Science in Kiel. And we have a very strong, talented young team to drive our products forward. So last, our business-to-business model is focused on selling and licensing hardware. We want to we will be wrapping services around that. We'll be doing that with partners. For example, certification as a service. We don't plan to have garages where cars roll into, but we plan to partner with specific people that have those kind of assets. Revenue, we believe by 2030 we can approach $50 million. We raised $2.6 million to date, and we're in the process of doing a $3 million round for about 25% of the company. First and foremost, that money is going to be targeted at business development, marketing, and then ramp up of our products and prepare ourselves for an A round.
Sorry, Clemens.
So,
yes, sorry. Perfect.
Yeah, so thank you. Okay.
No, thank you. Sorry, I was just checking the time, but thank you so much. I see that there is a question in the chat, so maybe you can answer, like write the answer so I can give the floor to our last speaker, Scarlett Dufy. Please, the floor is yours.
Can you see my screen?
Yes.
Perfect. Hi, I'm Scarlett, and today I'll be walking you through the journey from chemistry to commercialization. We'll begin by looking at the key challenges confronting the battery industry introduce Echion's XNO technology as a solution, and demonstrate its real-world impact through current applications and success stories. Both Echion and our development partners see this as a revolutionary product, and I hope coming away from this you feel the same. Sorry. We are living in the electric century, but the way we store and deliver energy is struggling to keep up with our demands. There are many challenges: slow charging, overheating, long downtime, or worse, systems that just can't keep up with the pace of progress. In short, the road to decarbonisation, while advancing, has not been smooth. There is a will to succeed and targets from the government that need to be met, but desire and good intentions, plus large amounts of money, will not be enough. Efforts to decarbonise our most challenging sectors remain hindered by the lack of suitable battery technology. We're at a crucial point. Who is addressing the electrification of heavy industries, rail, maritime, mining operations, AGVs, and other high-power battery energy storage systems? There is a way forward. A new battery material combined with expertise and knowledge, plus commercial relationships and know-how to transform these overlooked and underserved sectors. Today's lithium-ion batteries were not designed for the demands of fast, reliable, heavy-use energy systems. They're stretched to their limits in buses, power tools, trains, even grid storage. Why? Because conventional materials in the battery's anode, especially graphite, simply weren't built to handle ultra-fast charging or heavy cycling. The results? Risky overheating, long downtimes, and huge costs in thermal management. There is another way. We've developed something different, something better. We call it XNO, a patented niobium-based anode material that unlocks the full potential of lithium-ion batteries. XNO enables ultra-fast charging. We're talking 0 to 80% in under 10 minutes, safely, reliably, without the thermal risk of graphite or silicon-based alternatives. What's more, XNO has exceptional cycle life, maintaining performance across thousands of charge-discharge cycles. No swelling, no lithium plating, no fire risk. At the core, XNO is a mixed niobium oxide engineered at the atomic level for high-rate lithium diffusion. Think of it as a 4-lane highway for ions rather than a country road. That means faster charging, less heat, and fewer energy losses. And because it's produced using scalable, low-carbon processes, it's as sustainable as it is powerful. Let's talk about what this means for the real world. In heavy-duty applications, faster turnaround time leads to more uptime and lower total cost of ownership, because your asset is working for longer with lower running costs. For many applications, there is the need for high levels of safety and effective operation at extreme temperature. XNO can deliver that. Overall, a battery pack powered by XNO will deliver excellent energy density, fast charging, and long cycle life, the key metrics in operational electrification decisions. This isn't a lab project. XNO is ready now. There is a robust supply chain in place. We're producing at an industrial scale, 2,000 tonnes per year today, scaling to 2,500 tonnes soon. We're also building a network of cell and pack manufacturers, plus engineering integrators who work with XNO, using our cell design expertise on our project team to deliver new battery products for customers. To take XNO from the lab to commercialization, we created our own demonstrator. Mining relies on diesel power to drive its machinery and trucks. This brings challenges and risks to mining operations. Heat and exhaust fumes, noise and vibration, both having an impact on the health and safety of workers, plus refueling requirements that limit the mine's infrastructure and smooth operation. Electric vehicles will make mines safer and more efficient than diesel-only powered alternatives. To demonstrate how this could happen and to put XNO in a real-world situation, Echion worked with engineering partners Switch Technologies in Australia to develop a hybrid-powered Land Cruiser, a workhorse vehicle that is used across mining operations. What were the aims? To provide a mining relevant demonstrator of XNO cells, as a testbed for XNO cells being produced by our customers and scaling this up to module, pack and vehicle levels, and to build commercial partnerships and lead to the commercial uptake in the mining industry and beyond. The vehicle was launched in December 2024 and is currently undergoing testing and use, with data being collected and analysed to assess battery performance, safety systems, and the overall efficiency of the vehicle. To find out more, you can see the progress the team made with our video series by scanning the QR code on the screen. So, why are we here with you today? Firstly, we want to be a positive member of BEPA and work with this engaged community. We also want to tell you about where we are currently with XNO and some of the milestones we've achieved along the way. And we want to look ahead for bold, visionary partners to join us in bringing XNO to the world. We want you to consider your next development project. Can you work with Echion on something tangible, deployable and scalable that showcases what this material can do in your world? Together, we can prove to the market that safe, fast and sustainable battery tech is no longer a future promise. It's a present-day reality. That's the end of the presentation, and thank you for listening. I'm not sure how much time we have left, but if anyone has any questions, I'll try to answer them.
Yeah, thank you, Scarlett. I see there are some questions. Yes. NB anode has excellent rate performance, but the main challenge is their lower energy density. Which main application do you suggest for this? In EV competition is really hard. This is the question.
I think that's a great question, and I want to make sure that you get the most accurate answer. So I'm going to speak to one of my technical colleagues and I'll follow you up after the webinar.
Okay, thank you. I'm checking if there are other questions, but for the moment, yeah, I see. Yeah, I see a question in the chat. Are you looking into electrolytes optimization in your R&Ds for such anodes?
Again, unfortunately, I'm not the right person to answer that, but that is a really good question. So I'll definitely get back to you on that one.
Okay, so thank you. I think that all the attendees can then contact you. We will be sharing the recording with your contact information. So thank you, Scarlett, again.
Thank you.
Thank you all for your time, and I hope that you heard about interesting presentations, that you got useful insights, valuable insights from our speakers today. So I really want to thank you all, and wish you a good lunch if you have not eaten yet, otherwise a good afternoon. And see you soon. Don't forget, it is already possible to register to the third edition of our Battery Startups Lunch in September, on the 10th of September. And my colleagues have just shared the link in the chat. So thank you so much again, and I wish you a good day.
Thank you,
Thank you,
bye-bye.
everyone.
Thank you.
Thank you, bye.
And